So this is problem 1.35 of I.E. Irodov, and this problem is on the same lines as of the problem 1.34 as discussed earlier in the video of the radius of curvature. A particle moves in the plane xy with velocity v is equal to ai plus bx j, where I and j are the unit vectors of the x and y axis and a and b are constants. At the initial moment of the time, the particle was located at the point x is equal to y is equal to 0, and we have to find the equation of the particle's trajectory y as a function of x and the radius of curvature of the trajectory as a function of x. So you are given with v is equal to a I cap plus b x j cap. If you compare this equation with this vx I cap plus vy j cap, so we have x component of velocity vx a and y component as bx. So along x-axis velocity is constant, but along y-axis velocity is changing. So let at any instant of time, let the coordinates of the particle reaches p is say x and y. So we can write x is equal to vx into t, and that gives us a t by substituting the value of vx from here. So this is our equation 1. Similarly, we can write for y along y-axis the motion is accelerated, and you can calculate acceleration from here. Acceleration along y-axis is the differentiation of this as b dx by dt, and dx by dt is what vx, and value of vx is a, so we have b into a. So that is the acceleration along y-axis, and the initial velocity is 0 plus half acceleration along y-axis t square. So from here we get half acceleration along y-axis ab, and from equation 1 if we substitute the value of t here, so we will get x square by a square, and finally we get b by 2a x square. So we have this equation of y, so I'm writing it here, y is equal to b by 2a into x square. So we have calculated the first part of the question, the equation of the particle's trajectory y as a function of x. So this is our answer. Now for the second part b, in which we have to calculate the radius of curvature, and earlier I have also told you the formula for the radius of curvature as r is equal to 1 plus dy by dx whole square, and this complete raised to the power 3 by 2 divided by double derivative of y with respect to x and its modulus. Now in order to calculate this, we need dy by dx, and dy by dx from here we can write b by a into x, because differentiating x square will give us 2x, and 2 and this 2 gets cancelled, so we get this, and differentiating this equation again with respect to x, we get d square y by dx square, and it is equal to b by a, and substituting these values here you will get the value of r, that is equal to a by b into 1 plus x into b by a whole square raised to the power 3 by 2. So this is our answer to the second part.